In this lecture, we'll explore why Git is essential and why you, one, get hired without it. We'll start not with commands, but with the pain. Let's see what development looks like without version control. Folders like Project Final 2, Project Final Really, Final, and the fear of deleting the wrong thing. You'll understand exactly what problem Git solves, why it became an industry standard, and what employers specifically look for when reviewing your GitHub profile.
When you see folders on your computer with names like Project 2 or Final Edits Please, don't blame yourself for being disorganized. Absolutely everyone does this when they need to save different file versions without a proper tool. From students to experienced developers, everyone goes through this stage before discovering version control systems. Essentially, you've already invented versioning, just in its most primitive form. This isn't chaos, but a natural step toward understanding why we need Git.
Imagine you, saving a novel and saving a new copy every day. Novel draft, novel, final editor edits. After a month, you've got 40 files, and you can remember which one had that perfect version of Chapter 3. The main problem with this approach is that the change history exists only in your head, and human memory is imperfect and doesn't create backups. That's why you're afraid to delete old versions, even when they were clearly outdated.
When you were working alone, a system of folders with different versions might just about work. But as soon as a second person joins the project, all hell breaks loose. Someone accidentally overwrites others' work. The current version gets emailed around as a zip file, and within a week, nobody knows which version is actually final. The problem isn't to people or their carelessness. It's the lack of a tool that remembers the complete history of changes and can intelligently merge different people. Work. This is exactly what Git solves. But what does working without version control look like in a real project? Let's examine some specific scenarios where things can go wrong.
Imagine this. You've spent 2 hours working on a new feature, saved the file over the old version, and realized you is permanently deleted working code. Centralized only works within your current editor session. Close the tab, and the edit history is lost forever. Without version control, every save becomes a gamble. You never know if you will regret that action later. This isn't a made-up scenario. Every developer has lost hours of work this way at least once.
When you are not confident you can return to a working state, you become afraid to make changes to the code, even when they were clearly needed. You might want to refactor a module or try a more efficient algorithm, but the fear of breaking the working version is stronger. As a result, the code gradually degrades. Instead of improving what's there, you keep adding new layers on top of old code. This is in caution. It's a direct consequence of not having a reliable way to roll back changes.
When two developers work on the same file without version control, the inevitable happens. Whoever saves last silently overwrites their colleagues' changes. No warnings, no traces of previous versions, just a clean overwrite. And when something breaks in production, there's no way to determine who made the problematic change or when. This isn't about poor team communication. It's a technical problem that VC solves at a fundamental level. Having covered the problems, let's now look at the solution. How version control systems turn chaos into an organized history.
A folder full of files like essay edits to final submit this one docs represents an attempt to manually create a versioning system. And it works fine when the project is small. But when you have dozens of files and thousands of edits, you can't remember which version was current 3 days ago, or who broke the build. This is exactly the problem that version control systems solve, but they do it fundamentally differently from manual file renaming.
Imagine having a time machine for your code. At any moment you can return to last week, project state when everything still worked. VCS saves not just files, but snapshots of the entire project at every significant moment. It's like the version history feature in Google Docs, but for your entire code base. You see not just the last saved copy, but a complete timeline of changes that you can navigate in any direction. Such a system gives you complete control over the project, its development, and protection against accidental errors.
Every change in version control answers three fundamental questions. First, what exactly changed in the code? Which lines were added, removed, or modified? Second, who made these changes? And third, most importantly, why it was done. It's the answer to the third question that transforms change history from a set of edits into meaningful documentation. 6 months from now, you'll be able to review the history and understand not just who changed what, but why it was necessary. But how exactly does version control store all this information? Let's look under the bonnet of the version control system.
Every saved change in Git isn't, just a modified file. It's a structured record with 4 key parts: the author, who made the changes; the timestamp, when it happened; the commit message, why it was done; and a snapshot of all project files at that moment. This structure turns chaotic edits into a readable history where each entry has its own context and justification. It's like a passport for every change in your project.
Contrary to popular belief, Git doesn't just store the differences between file versions. Instead, it takes a complete snapshot of your entire project state with each commit. If a file hasn't changed, Git doesn't show a new copy. It simply creates a reference to the existing version. This approach allows you to instantly switch between any point in history without needing to sequentially apply or undo changes. Imagine it like having a photo album where you can instantly flip to any page, rather than having to reconstruct each photo from the changes since the last one.
The git log command opens up a journal of all changes in your project, starting with the most recent. Each entry contains a unique commit identifier, author, date, and message. This isn't just technical information, it's the story of how the project has evolved. Good, meaningful commit messages transform this log into valuable documentation, while messages like fix or update render it practically useless. Now that we understand the basics of VCs, let's explore how these systems have evolved, and why the centralized approach gave way to distributed version control.
In systems like SVN or CVS, there's a single central server that stores the entire change history. Developers work with local copies of files, but all operations involving history require connecting to the server. It's like a library with only one copy of each book. To work with the text, you must first check it out from the server, and then return it. While you have the book, no one else can work with it. This creates certain limitations for development teams.
The main vulnerability of centralized systems becomes apparent when the server fails. The entire team grinds to a halt. No commits, no access to history, no way to continue work. If data is lost without a backup, the entire project history disappears. This isn't just theoretical. Many teams have lost months of work due to such failure. One mistake, and the library burns to the ground, taking all accumulated knowledge with it.
As teams grow, the limitations of centralized architecture become increasingly problematic. When one developer locks a file, everyone else is left waiting. Slow connections turn every operation into a test of patience. The server, meant to facilitate work, becomes its biggest hindrance. This very problem led to the creation of a fundamentally different approach, where each developer maintains a complete copy of the entire project history. And this is where Git enters the stage, a system that revolutionized version control.
In a centralized system, the entire project and its history are stored in one place, the server. If it becomes unavailable, the team loses not only the ability to save changes, but also to view history or switch between versions. 10 people might be idle because of one computer. This is a classic bottleneck. The larger the team, the more severe the consequences of each outage. Imagine your entire workflow depending on a single button. If it breaks, work grinds to a halt.
Git operates on a different principle. When you clone the repository, you get not just a copy of current files, but the complete project history. Every commit, every branch, every version, it's all stored on your computer. It's like being given a complete copy of every book in the library, rather than just a library card. Now, you can work with the project history anytime, even without an internet connection.
Git's distributed nature gives you 3 fundamental advantages. First, you can work offline, commit changes, browse history, and switch between branches without an internet connection. Second, your project becomes resilient. If GitHub were to disappear, any local copy contains everything needed for recovery. Third, you have complete control over when to share your changes. No one sees your code until you decide to publish it. But why did Git, rather than other version control systems, become the industry standard? The answer lies in its origin story.
Git emerged in 2005 for good reason. The Linux kernel was being developed by thousands of programmers worldwide, and existing tools couldn't handle the scale. When the proprietary BitKeeper system revoked its free license, Linus Torvalds wrote Git in just a few weeks. It's crucial to understand. Git was created to solve real problems in the world's largest open source project, not as an academic exercise. This is why it performs so well in any scenario, from a small personal script to a massive corporate codebase.
Git success is built on 3 key advantages. Instant branching. Creating a new branch takes a fraction of a second because it's just a pointer, not a file copy. Reliability. Every commit is protected by a cryptographic hash, making history tampering practically impossible. And complete autonomy. You can work with the entire project history locally, without server access. Each of these features solves specific problems that developers faced with other version control systems.
Today, over 90% of developers use Git. It's not just a popular tool, but an industry standard. However, it's crucial to clearly distinguish between 2 concepts. Git is a program installed on your computer that manages version history. GitHub is a cloud platform for storing Git repositories and collaborating on them. Git works perfectly fine without GitHub, but GitHub cannot exist without Git. When an interviewer asks about Git knowledge, they mean the tool itself, not the web interface. Understanding this distinction is key to grasping the entire ecosystem.
Many beginner developers dawn to see the difference between Git and GitHub, considering them the same thing. This confusion leads to misunderstandings. Where exactly do changes go when you run Git push? How does synchronization work between your local repository and cloud storage? The sooner you understand these differences, the more confident you will feel working with version control. Think of Git as your personal notebook, and GitHub as the team's shared whiteboard.
Let's set the record straight. Git is a program installed on your computer that works locally. It manages change history, creates commits and branches. All this happens on your machine, without internet. GitHub, on the other hand, is a web service, owned by Microsoft, that provides cloud storage for Git repositories. The key point is this. Git works perfectly well without GitHub, while GitHub is entirely built on Git's capabilities.
Let's draw an analogy. Git is like Microsoft Word, a program on your computer for working with documents. GitHub is like Google Drive, a cloud storage for those documents. Word exists without Google Drive, but Drive without documents would be pointless. Similarly, Git doesn't depend on GitHub, while GitHub wouldn't make sense without GitHub. And remember, besides GitHub, there are other platforms like GitLab or Bitbucket, but they all use the same Git under the hood. Now that we've covered the tools, let's discuss how your code appears in the eyes of a potential employer.
Your GitHub profile is much more than just a code repository. For recruiters, it's the first window into your professional world. In just 30 seconds of viewing a profile, they can form an impression of you as a developer. 3 key elements that catch the eye: the activity graph, pinned repositories, and the presence of README files. This is your interactive CV that speaks for itself.
The activity graph shows your consistency. 10 commits per day over a month makes a better impression than 300 commits in one weekend. Commit messages reveal your thought process. Fix, corrected discount calculation, says much more than just update. And having a README in your repository shows that you care not only about the code, but also about those who will work with it after you.
An empty GitHub profile is a missed opportunity, but there's something worse. Repositories with commits like test, AAA, or fix. Such messages are a red flag for employers, signaling a careless attitude toward work. Pinned repositories should showcase your best projects, not random experiments or coursework. Remember, quality always trumps quantity. Now, let's examine the most common mistakes that junior developers make when maintaining their profiles.
One massive commit per month suggests you're putting off saving changes until the last minute. Hundreds of forks without original projects create an illusion of activity, but don't demonstrate your skills. Repositories with names like test, 1, 2, 3, or with just one commit give an impression of carelessness. It's better to have 3 well-presented projects than hundreds of unfinished drafts.
One of the most serious mistakes a junior developer can make is uploading a file containing passwords or API keys to a public repository. Even if you delete it immediately, the history remains, and GitHub bots will have already indexed it. The solution is simple. Create a JIT-ignore file and specify all files containing confidential information. This is something to learn before your first commit, not after your keys have already been exposed.
The perfect GitHub profile isn't about the number of repositories, but the quality of work. Regular commits with meaningful messages, using feature branches, clear README files. All of this shows you understand the development process. 3 well-presented projects will tell more about you than 20 unfinished ones. Remember, your profile is your professional business card in the development world.
Imagine that until today you've been keeping all your belongings in one big pile on the floor. Now, you have a wardrobe with shelves. That's what Git is. Your homework is to look into other developers' wardrobes on GitHub and understand how they organize their code. It's like looking into house windows in the evening. You'll see how professional teams actually work. And in our next lecture, we'll install Git together and take the first step towards organizing your code beyond just a pile of files on your desktop.